Sam Phippen, ladies and gentlemen.
Smoky hug, smoky hug.
Hi, everyone. Hi, Sean. Just to clarify before I get started, I'm not actually a fan of single-page web apps. You can search Twitter for the string single-page web apps don't work to find my opinions on them in excruciating, endless, painless detail going for days and days and days. Anyway, let's talk about extremely defensive coding. PJ introduced me, but just to add some social media credentials, I'm Sam Phippen on Twitter, Sam Phippen on GitHub. You can take a look at my profiles in either of those places if you're interested in finding out more about me. If you do take a look at my GitHub profile, you'll find that I spend most of my time on GitHub committing as a member of the RSpec core team. And that's one of the reasons why I'm here today. I think it's really important that RSpec is well represented in community events like this. I love talking about the framework, hearing questions, getting feedback, and that sort of thing. So if you see me walking around the conference later today at the party or tomorrow, please feel free to just come and have a chat with me about what you think about RSpec. I'd love to talk to you about it. I work for a company called Fun and Plausible Solutions. We're a consulting agency based in London that specializes in things you might expect, like Rails refactoring and testing and software architecture and design. And if any of that is interesting to you, if you'd like to work together, please come and have a chat with me afterwards. I wanted to start this talk with a story, and the story actually comes from a question session on one of my other talks about the architecture of RSpec mocks. I gave it at a Ruby user group in the UK, and there was a really wide range of people in the audience, as you might expect, from junior developers all the way up to the most senior people I respect and would love to work with. And as I was sort of answering questions, we eliminated some of the more technical ones. And one of the beginner developers in the room asked me a question that genuinely stumped me for a moment. They asked me, when is it OK to override the methods that are given to you by kernel, by object, that are basically on every object by default? Part of my talk was reasoning about why RSpec is so complex, given that it has to deal with user objects. And this is one of the things that I cited as a problem. And this question actually floored me. I wasn't sure immediately how to respond. One of the reasons I love working with junior developers is I have all of this knowledge in my brain about how I think software works that I don't have to make explicit most days. But when you're faced with a question like that, you can't give a half explanation. And as I sort of began to give examples and began to structure my answer, I realized that I wasn't actually explaining what I thought in a way that was clear to the developer. And so anyway, I took a pause, I thought for a second, and I came to an answer to do with consistency. Basically, what I said is that overriding methods on objects should be done when it makes the object behave more consistently with other Ruby objects, not less. When you're redefining a method, you can make it do basically anything, but if you make it more consistent with the other objects in the Ruby system, you're probably onto a winner. And a quick example of this is double equals on a data object. If you're inventing your own collection type, it might be the case that making its comparison work with other things that are contained in it be more consistent than object identity. And there are other examples that I could give, and I'm not going to go into too much detail because I don't have time, but hopefully that gives you something to intuit with. And I'd like everyone in the room to just hold on to that story as I go through the rest of my talk. I wanted to talk about what it means for a gem to be good, and what actually makes a gem good when we're working with code in Ruby. As I've been thinking about this question, the first thing that I sort of came to was, well, what about the internals of a gem that we're going to be working with in our Ruby system? How much do they matter to whether or not a gem is good to us? Well, certainly, poor gem internals can make it harder for the gem authors to do releases and fixes and keep a gem well maintained. But I look at a lot of gems, and I see complexity on the inside, and I know that I'm able to use those gems much more easily than the complexity that's in there. So it's clearly not the internals that make a difference. So what about the interface? Well, to me, when I work with gems, the interface is my sort of hopping off point. It's where I stop caring about what's going to go on with the software. And so, to me, an interface to a gem is perhaps one of the most important things that can make it good or bad. I would present you the argument that I am a pretty capable Ruby developer. Certainly not the most capable, but okay. And this means that for any particular task, I can probably implement whatever behavior a gem has myself, given enough time. And so if I'm presented with a gem, I have to ask myself the question, is this going to be more convenient for me than if I'm going to do it myself? And more importantly, not is it just convenient right now when I need that functionality, but is it going to stay convenient? As my application grows, as my objects become more complicated, as I maybe have to pull some hacks in order to get everything working, is that gem going to continue to grow and work with my application? Most people don't work in isolation on their applications. They work in a team. And that team's going to have a range of skills. And so if I'm going to use a gem, can I be certain that everyone on the team is going to be able to use it? And when they write their code and pass it into that gem, is that going to do the same thing? Most people don't run on multiple Ruby interpreters. But some of us do write code bases that have to execute on a really wide range of Ruby interpreters. And so when we do, can we be sure that package of code is going to work? Now, this might sound like a really demanding list, but let's put something near and dear to all of our hearts under the microscope and see how it comes out. Let's talk about RSpec. So I could tell you that RSpec is definitely always convenient, but that would be an abject lie. I'm sure all of you in this room at some point have taken something that you expected to work in RSpec, and it's fallen over, and you've been sad and miserable, and you don't understand why it's not working, and it's making you upset. This has definitely happened to me, and I stare at the insides of RSpec basically every week. So, not always convenient. I wanted to talk specifically about a user story from inside RSpec, inside our mocking library, to do with what happens when you stub an object. And so I'm just going to get a little bit agile on you now. I hope that's fine. If you're allergic to agile, shield your eyes. As an RSpec user, when I stub an object, I want the original method to be on that object after the example is done executing, so that my tests aren't broken by my test suite. That was a bit fast, so let's break it down a bit more simply. As an RSpec user, that's, according to the Ruby survey, 70% of you in this room. When I stub an object, that is, taking an object and replacing one of its methods with an RSpec implementation, which is a stub, to presumably reduce the amount of complexity you have to reason about in your test, I want the original method to be on that object after the example is done executing. That is, when the test is done, the RSpec stub implementation should go away, and we should replace it with the original method implementation so that that object continues to function, basically because you don't want stubbed implementations flying around your code necessarily breaking things. Stubs have a lifetime over just a single test in RSpec, and so you want to make sure those are reliably reset when you're done. Now that I've explained what I want, let's talk about how it works. To clarify all of the English that I just said, we're talking about when you write an expression like this in RSpec. Allow x to receive foo. What this does is it takes the foo method off x, puts it somewhere else, and puts a stub implementation on there instead. So we remove, we save it elsewhere, we execute our test, and then we put the original method back on the object. Now, it's my suspicion that most of you don't spend all day in your Ruby programs moving methods around as if they were data. This is not a common task in Ruby, and so I'm going to explain how this works using actual Ruby method calls. If you go into the Ruby standard library and look at the documentation for object, you'll find this paragraph. Object has an instance method on it called method, which takes a symbol and returns whatever RDoc is telling us a method is. The doc string reads, looks up the named method as a receiver in obj, returning a method object or raising name error. The method object acts as a closure in obj's object instance, so instance variables and the value of self remain available. That's pretty obtuse, so let's break it down. In Ruby, a method object is an object that you can pass around, just like any other object in the Ruby system, that represents a single method on a single object instance somewhere in the Ruby system. It has a self, and it has access to all the instance variables, and so as you move it around, you're effectively moving the literal representation of that method around your Ruby system. Method objects have a public method called call, which takes as many arguments as the original method that you pulled off an object does. And so you're basically moving this thing around as if it's an object, and when you want to invoke it, you can call the call method, and that's exactly the same as just directly invoking the method, plus or minus a bit of Ruby interpreter details. So once you have a method object, you can put it somewhere else, and in RSpec, we put this on an object called a proxy. When your test is done executing, you just grab the method object from the place that you saved it, and you basically restore it onto the original object. So we've solved our user story, and I could tell you that that was the end of my talk, but unfortunately that would be a lie, because the actual truth of how RSpec moves method objects around in Ruby is way more complicated than that. And in order to talk about it, we're going to have to talk about the titular defensive coding. So, in RSpec, instead of directly invoking the method on an object when we want to move a method around, we call a method called RSpec support method handle for. This method basically exists because simply invoking the method is not good enough in most cases. And what I'm going to show you now is a brief evolution of RSpec support method handle for over the last couple of years. One thing to note, this isn't exactly how it happened in the Git history. This is a linearization for this talk, but it should illustrate the points, and I hope it'll be interesting. So this is the first implementation of RSpec support method handle for you'll ever find anywhere in the RSpec source base. Basically, it's a method which takes an object and a method name, and it invokes the method on the object with the method name, returning us the method handle. This basically just wraps the Ruby standard library definition, and there is no magic here. Now, I said that this isn't good enough, and that's partially because in Ruby, users lie. How many of you here have ever done anything to do with the web in Ruby? Basically everyone. If you look inside most HTTP libraries, somewhere, you'll find a method that looks something like this. It doesn't have the same number of arguments as the method out of the Ruby standard library, and it will return a string or a symbol, get, post, put, whatever, to represent an HTTP method in that domain. Now, unfortunately, what's happened here is when the user does this, they've blown away the metaprogramming method we need to pull method handles off objects. And that's fine. The word method means something in the domain of HTTP. The Ruby interpreter doesn't get to lay claim to it. And so I would highly encourage you to do this, as long as the thing that you're doing is sensible and makes sense in your domain. In Ruby, users can and will redefine any method out from underneath you at any time for no particular reason. And your gem should be able to deal with that. Which leads to the second implementation of RSpec support method handle 4 you'll find, which looks like this. What we have here is a constant called kernel method, which gets assigned the value of the call kernel.instanceMethod method. The instance method is like the method, except it returns instance method objects, not method objects. The difference between an instance method object and a method object is that an instance method object does not yet have a self or instance variables or a target. It's not only waiting for arguments, it's also waiting for an instance to be bound to. Basically, you can think of this as the implementation of a method without it being attached to any particular object instance. Instance method objects come from classes and modules, not individual object instances. And so basically what we're doing here on this assignment is we're grabbing the kernel implementation of the method and saving it for later. When an object flows into RSpec support method handle 4, we bind the kernel implementation of method to it, and then we call it with the method name. This basically does exactly the same thing as calling the method. It's just relying on kernel's implementation, not the one on the object. So if a user redefines the method, we can still reliably pull method handles off the object. Once again, and this bears repeating, in Ruby, users can and will redefine core methods out from underneath you at any time. And if you're going to use a gem which invokes methods on your objects, you better be sure that those are going to be there and they're going to be reliable. In RSpec, if possible, we tend to prefer kernel's implementation of something to a user's. And the reason for this is absolutely nobody opens up kernel and does stuff to it. Because why would you? Kernel is super core to Ruby. Don't screw with it. The next one is that Ruby interpreters lie, or at least have wildly different implementation characteristics depending on what you're doing. So it should not surprise you to learn that some objects in Ruby do not have kernel in their inheritance chain. And immediately, I'm sure some of you, your minds will have jumped to basic object, which includes basically nothing. But I'm actually talking about objects that look more like this. In the Ruby standard library, there are a number of objects which inherit from basic object and then include a dupe of kernel. Whilst it means that this object has all of the methods that object has on it, it doesn't have kernel in its inheritance chain. And that can cause problems when that name isn't there. Just to quickly remind you, this is our current implementation of RSpec support method handle 4. And if I execute this on the latest version of MRI, it works and there's no problem. But if I switch to JRuby and run it, I get this exception. Bind argument must be an instance of kernel, bind at location, whatever. Basically, what we're doing here is called rebinding module methods. And under that particular version of JRuby, that is not something that is supported for modules which don't have the other module in their inheritance chain. I'll explain in a second. The thing about RSpec is it's the individually most widely deployed testing suite in Ruby according to the Ruby survey. And so we have to support just about every Ruby interpreter on the planet. When we released the last major version of RSpec, RSpec 3, we made the decision to continue to support Ruby 187 all through the RSpec 3 series. We also support all versions of MRI, versions of JRuby, and even REE. How many of you are still using REE in production? I bet it's like a very small number. Sean's just like, I make Rails! I have to! Yeah. And so, given that we have this wide range of support, also today, this total aside, I was like tweeting Koichi, help, I don't understand why a thing isn't working on 187, and he's just like, throw away 187, and I'm like, okay, we can't, but sure. So there you go, throw away 187. RSpec doesn't support Rubinius. We really tried. We did a lot of work. We tried to reach out to the Rubinius team. This isn't meant to be a slight on Rubinius in any way. It's just that we couldn't get our stuff working. And to quote Charles Nutter, the RSpec mocks test suite is like a stress test for the metaprogramming inside any Ruby virtual machine. So yeah, I mean, if you're super awesome at Rubinius and care about RSpec, please get in contact with me and let's sort it. So, module methods. This problem caused the implementation of RSpec support method handle 4 to grow to look like this. Do not pay too much attention to the details, but the first thing to note here is that the methods are defined conditionally based on the thing called Ruby features. And basically, this gives us different implementations at Ruby interpreter boot time because we know whether or not the features we need in our Ruby interpreter are present when it boots. So if we look inside the Ruby features supports rebinding module methods method, it looks like this. If we're running on MRI, then the answer is our Ruby version greater than 2? Otherwise, we create a module, we pull an instance method object off it, we rebind it to an object, and then if that works, we return true. Otherwise, we return false, which gives us that conditional. If we do support rebinding module methods, then we can always use kernel's implementation, because our Ruby interpreter isn't going to blow up. And if we don't, we have to type check that the object belongs to kernel. If it does, then we can use the kernel trick. Otherwise, we have to invoke the user's method. That was intentionally quick. You probably didn't get it, and that's fine. Ruby interpreters behave differently on different platforms, and that's really important to understand when you're writing a big, complex gem that's going to be deployed everywhere. And knowing how to defend against those differences is really, really important. Just to show you this is real, if you look inside the Ruby standard library at Simple Delegator, which is in the delegate module, Simple Delegator inherits from basic object and includes a dupe of kernel, not kernel itself, and Simple Delegator is a sufficiently commonly used object that this is something that we had to support. Sometimes, users don't lie. And to demonstrate this, we're going to look at this code snippet, which is quite big, but basically, there's a class called bar, which has a single public method called foo, and then I've got a class called foo, which implements respond to and method to delegate onto bar for part of its responsibilities. So that is, if bar responds to a method, then foo does as well. And if you call the method on foo, it will delegate onto bar first. Basically, we have an implementation of the method here, which is correct. We can pull method handles out of this object, even though it's not using the default implementation of the method. If you run this script with the current implementation of RSpec support method handle 4 I just showed you, you get this error, method undefined method foo for class foo. Basically, because we're using kernel's implementation of the method and not the objects, we get this exception because the kernel implementation doesn't know about this delegation. Basically, the kernel implementation is wrong, and we're not sure whether or not we can trust the user implementation, which makes this a fun catch-22. The solution we have inside RSpec is a trust but verify type approach, where we use our original kernel method rebinding trick, and if that doesn't work, then we invoke the user's method, returning a method handle, checking it's a method handle, and then raising exceptions otherwise. So let's see what this method looks like when we put it all together. This is the final implementation of RSpec support method handle 4 as it stands inside RSpec today. It is big, it is messy, it is complicated, and it is the most reliable method I have ever seen for pulling a method handle off an arbitrary object in the Ruby system. That's its true power. Sort of to wrap up, this is one of the reasons that I love RSpec and I love working on RSpec. We will go to extreme lengths to make sure that the framework works for you, as long as the thing that you're doing could be considered valid in some context. One of the things we like to say is that if you can express it in the RSpec DSL and it's valid, it should probably work for you. And there's a bunch of caveats around that I don't have time to go into now. If you're doing something with RSpec and it doesn't work for you, it's probably a bug. Obviously, check your tests are sensible first and maybe ask somebody else, but I find that people tell me things are broken in their RSpec suites and I look at them and it's totally a bug. Please file bugs. We love it when we get bug reports. Even if it's not an issue with RSpec, it probably means that our documentation wasn't good enough, and so we'll update that so it's more obvious how to do the thing correctly in the first place. The things I've been talking about are talking about making a gem defensive to user objects. Users are going to redefine methods out from under your feet at basically any time. And if your gem is going to invoke a method on a user object, you better make absolutely sure it's going to work. Your code is going to run on many different Ruby interpreters, most of which are compatible most of the time, but it's those most keywords that are really, really important. Ruby users can get kind of weird, and that's one of the reasons I love this community. You've got to trust their methods, but also verify that the thing they're doing is sensible. At the beginning of this talk, I posited the question, what makes a gem good? And I also asked whether or not we think about the internals when we do that. Well, I would construe that the explanation that I've just given about how that piece of RSpec internal works makes absolutely no sense. Most people in the room don't need to know about all of that complexity. RSpec hides that complexity for you, and you just get to use something that works. It's the interface that's really, really powerful here. You just type allow X to receive foo, and this giant machine comes to life, working against your objects to work out what's going on, what you've changed, allowing you to basically do anything in your domain that makes sense, and RSpec will do the correct thing. You get all of that hidden complexity of working with RSpec absolutely for free, because that's how the maintainers want it to be. You probably didn't even know there was that much horrifying code in there until I just told you. So our interface, I think it's pretty clean, and it gives you all of this power. So what are gems? I came up with this explanation quite recently, and I think I kind of like it. If an object is a barrier inside of which you can hide code, then a gem is like a really big barrier in which you can hide lots and lots of code. Done badly, a gem is going to cause a huge mess and make everyone's day really, really sad. But done correctly, you can hide unbelievable layers of complexity behind a really well-defined barrier that doesn't change and allows you to make users' days great. Making your gem defensive helps your users get their job done without ever having to look inside your code. And most of the time, a user shouldn't have to open up a gem in order to be able to work with it. I think this is something we should strive for, users never looking inside the box. Unless they want to because they're interested. So remember the story at the beginning of this talk about the junior developer? Well, for me, this talk is really born out of the power Ruby gives us to do anything we want. But to be a bit cliche, with great power comes great responsibility. And if we're going to write code and distribute it to the ecosystem, I want that code to be as good as possible. I want it to work with a wider range of objects as possible, and I want it to be defensive, so that we don't make mistakes today that we're going to have to pay for tomorrow. Thanks very much for listening. I'm Sam Phippen, Sam Phippen on Twitter, Sam Phippen on GitHub. My email address is sam@funandplausible.com if you want to have a long-form conversation. Thanks. Questions?
Does anybody have any questions for Sam or his beard?
Do you have any tips on how to define that interface and come up with like what's the best interface for a gem?
So that's a really good question. I don't have anything really concrete. I know in Sean's talk tomorrow, he's going to talk a little bit about how he defined the new active record interfaces, which I think is really interesting. A lot of the work we did with that interface in particular was done to keep it backwards compatible with the existing RSpec should syntax. And so it was sort of born out of that. I think, yeah, you know what? I don't have a good answer. I really don't.
Any other questions?
Yeah, you talked about keeping RSpec compatible with loads of different versions of Ruby all the way back to 1.8.7.
Yeah.
I think. Sorry, I'm not really come up really with the question, but I didn't want you to count down. That's why. So you're counting down, man. What's the reason you decided to keep it compatible with so many different versions? Because I think, isn't there a massive benefit to, like, if you dropped 1.8.7, 1.9, in fact, Ruby 1 completely, and just stuck with later versions of Ruby, wouldn't that benefit the users who are keeping up to date and make RSpec faster for them, and just more useful and easier to maintain?
So. Absolutely, 100%. Continuing to maintain RSpec on 1.8.7 makes it harder. Like when I first open a pull request and Travis returns the build, like it's always broken on 1.8.7, like 100% of the time. But the thing is, when we released RSpec 3.0, which was just over a year ago now, there was still a large enough proportion of 1.8.7 users that we did not feel comfortable dropping support. So the only version of Ruby that we dropped support for in the RSpec 2 to RSpec 3 transition, it was Ruby 1.8.6. Yeah, we were still supporting Ruby 1.8.6 up to about a year ago. Don't talk to me about that. But the thing is, other gems in the ecosystem continue to have this behavior. Bundler still supports 1.8.7 and up. In terms of the future, the plan is whenever the RSpec 4 release comes around, which we're hoping will be faster than the 2 to 3 cycle, we will drop 1.8.7 support then, and we'll take a sort of view as to whether it's sensible to drop 1.9 support as well. In terms of compatibility things, one of the biggest things it prevents us from doing is using the new hash syntax and keyword arguments. So that could be a benefit. I don't know. To be honest, I don't find the syntax restrictions to be all that problematic. One thing it does do, and also you mentioned performance. So I don't think we actually see a significant performance degradation because we're required to run on older Ruby interpreters, because you still get the performance benefits from the new ones. Those are in the interpreter. It's not like we build and release Ruby 1.8.7 code and that's all we do. But yeah, we just didn't want to be the reason to force people to lose their ability to continue to use modern versions of RSpec. And certainly it's a big win that Bundler can use modern RSpec for testing. So I don't know. At the end of the day, it's definitely a maintenance burden, but it was one that at the time we were willing to pay. And then my suspicion is we will definitely drop 1.8.7 whenever we have the next major version of RSpec. 1.9.3 and so on, not sure about. Yeah, and we can't do that, sorry, and then we can't do that until we have another major version because of Semper. That's my piece. Sorry.
Thanks very much.
Why are you sorry? This is like what you do. Your job. Don't apologize to me. All right, so I think that's going to wrap it up for Sam. So let's have one more round of applause for Sam Taylor Swift Phippen.